For this next video, you have to have watched Zebra command line and Zebra script. Because what we're going to do is we're going to turn the script that we had before, zebra.m, which starts on line 1 with some preliminaries and ends with the printing of a figure. Let me run it first by typing zebra. Let me run it again by hitting the editor button and then the run button. Same thing. I don't like the fact that a script is an open input and output thing where once you've run it, you have a whole bunch of variables in your workspace and it's going to end up confusing. What we need to do is turn this script into a function. A function is something that takes input, treats everything internal, and then perhaps returns output. It's as simple as making some space on line 1, writing the word function, space, writing the name of the function which has to correspond to the file name that you have, and then saving it. Right now, this function does not take any input, does not produce any output, but if I start from a clear workspace with no variables, clear my figure, and I run it, I'm going to do what the function is doing. Everything has happened internally, so all the variables stay inside. With this though, I can give it input. And let me define a first piece of input with a variable that I'll call WT. I cannot provide an input and then clear everything. That would get rid of everything, so that has to be gone. To show you that whatever you put in is inside, right now it's unused, let me just print it by just evaluating it without the semicolon. And now Zebra can be called from the command line with an input. And that input is going to be, let's say, a number, 1, 2, 3. And sure enough, the 1, 2, 3 now exists inside. It doesn't make it to the workspace, but inside of it, it had it, it returned it, and it worked with it. As soon as you provide some input, you owe it to yourself to write some explanations. Zebra, WT, loads the image of a zebra and does something. Right now, I'm going to tell it that the input is WT, to be defined. Later on, there will be some output, and at this point, I should say, last modified by me on August 10th, 2016. What I'm going to try and do is use this input WT to threshold my image. Remember, we load the image, we find out what class it is, we assign the colors, we call them something, we make histogram parameters and we plot it and we do something. We plot histograms of the colors and we make a print out of it. This was covered in Zebra script. As part of my calculation, I'm going to do something with the input. Use the input parameter. What should I do? Well, I'm going to say perhaps I'll make a condition on R. What's the condition? That shall be that red is smaller or equal than WT. In order for me to build my function, it's probably wise to just copy the lines until you're making some change straight into the workspace such that you have them. Ultimately, they'll be inside of the function. Right now, WT is 1, 2, 3, as I'm doing right now. And the condition that I'm asking for is, when is red smaller or equal than WT? The result of this thing is going to be a whole set of 1s and 0s, all logical values, which are now going to scroll across my screen. If I want to check what I just did, well, there's an answer now because I didn't call it anything. That answer is a logical yeses and nos. The 1s are the positions in the vector or matrix red that are indeed smaller or equal than that number WT. The 0s are where that condition is not met. I want to make a condition on green, where green is smaller or equal than WT. I'm going to make a condition on blue, where blue is smaller than or equal than WT. What I can now do, I can map the color where the condition was met to another color. Map the colors where the condition was met to another color. So if I say red, where the condition was met, now I'm using the logicals directly as input, identifying yes, yes, no, no, where the condition was met. If I change this to another value, perhaps I can set all those reds to 0. Maybe I can change all the greens where the green condition was met to 0. And maybe I can set all the blues where the blue condition was met to 255. As you see, I provide an input, that's WT. I load my image. I use the condition. I'll align it. I reassign. And then I change the picture that I had, change the array containing the picture to something else, namely the newly assigned colors. The reds, what will be the greens, what will be the blues, are going to be my new reds, because I reassigned them. My new greens that I have reassigned, and my new blues, which I have reassigned. At this point, I've used my condition, my x has become something new, and now I go on with the plot as before and the figure making as before. How do I run this? Well, I'm going to clear everything to show you everything is internal. There are no variables in the workspace. I call Zebra using the parameter, let's say, 25. This is going to look through all the channels and replace all the values where the individual colors are smaller than 25 in this case, to a new color, which is 00, 255. Okay, that should be returning a zebra with mostly blue stripes. And if I'm a little bit more stringent or a little bit more liberal, 50 is going to take more areas that are less black into blue. 5 is going to change fewer areas into blue. In other words, this is very black, now blue. This is more or less black into blue. This is even more so. Now you see I'm hitting more than the zebra. And every time the histogram changes because that which was originally not changed, this is the original at 0, has now taken all the values that were below 50 and mapped them onto 0 here, 0 here, and a lot of blue there. So take a look. I've created gaps below 50, mapped them all to 0, and mapped all of those places to blue. So now I have a complete function that allows me to threshold the values according to this threshold onto a new picture which it plots, displays, and analyzes. Perhaps we would want to make 3 thresholds. Maybe I want to say this is a threshold color in the form red, green, blue, below which the original colors will be mapped to 00 to 55. I do like the idea that if I only give one number, that applies to the same value 3 times. So I'm going to build another control structure in there and say, if the length of WT is 1, make a WT that really is WT repeated. Now if I stick in the number 50, it's going to really check every channel for 50 and 50 and 50, as long as, of course, I update the lines here by using the first, the second, and the third value of my input. I'll check. Zebra 50, I shouldn't see a change. Zebra 50, 50, 50 doesn't produce a change. But now I have the flexibility of maybe thresholding this at 5, this at 25, and this at 55, and I'm taking slightly different decisions. Every time I get a different threshold for every value. The idea of having a function is very, very useful. Now, this just took one input and it produces no output. I suppose I could return my new image, which I'm reassigning, as an output. And that's as simple as saying, well, whatever internally was x, make it an output. Because you might want to do something or look at it. At this point, I say, my output will be the new image array. I run this, it's going to stream this output across my screen. If I terminate with a semicolon, it'll be silent. I'm going to want to do some more things. I'm going to want to produce another output. And how about I try to keep track of which conditions are being met. Inside of here, cond R, as you recall, are logical arrays with zeros and ones. Something like this here. Logical, which is a Matlab function of, I don't know, 0, 0, 1, 1. And the number of things I'm changing is wherever it hits 1. Turns out I can collect this number as the sum of this logical, which returns a number, which actually is 2. This is a double. It's a number I can calculate with. It's no longer an image number or a logical number. It's actually just a real number. So I could say, give myself some output and say, tell me what's going on. Since I'm changing values, I'm going to align it. How about I display a formatted statement beginning and ending with a new line that says changing how many, an integer, reds, how many greens, how many blues, that's the format string, which now needs the numbers that are being changed. And that's just a sum of where the condition is met in the red, the green, and the cond blue. When I now run this, it's going to tell me what's changed. This, however, is too much information, and the reason is that the conditions are arrays of ones and zeros, and sum really gives us the sums across the rows for every column. So really what I want is a complete summary of the totals of the totals. I could use sum of the sum, or I could sum of the concatenation of all these things in array form. Rather, what I'd have is the sum of the sum, or the sum of the concatenation of all of these things, treating it as a one-dimensional array each. Now run this, I should only get 3 pieces of output, stated once. Perhaps I should do something else, and perhaps I should say, well, I'd better refer this to the image size. Well, what's the X size? It's going to be the product, the channel size maybe, is the product of the size of, say, the reds. Size of red will tell me this many rows by this many columns. The product of that is the total length of the entire unwrapped red vector. And the reason I'd like to do that is I'd like to normalize the sum of the changes by what I have to change. Now it's a fraction. Now it's a percentage. And now it's a rounded, approximate percentage. Of course, it's not 15 reds, it's a percentage. Well, the sign for percentages, it's a format for a percentage. Double, double. Run this. That's the percentage I'm changing. There is no limit to the complexity of what you want to do. Perhaps you want to combine conditions using and or statements and make a general condition. Perhaps you want to assign a new color that isn't blue to what you're changing. In this last case, we would say new C for new color. This is new input. Red, green, blue. Of the reassignment color, which I would then apply by saying new C1, new C2, new C3. The old behavior is the same as saying I was going to replace the red conditions by 0, the green ones by 0, the other ones by 255. I won't change it. If I want to change the conditions being met to a yellow, perhaps, I'll change it to 255, 255, 0. Is that yellow? I'm colorblind. It's red. What would this be? Purple. Green and blue. And so on. In other words, I can make up a new color. And we're going to try a few more things. 50-50, changing them to green. This color. This color. And so on. So, whenever you decide you're going to want a new input, just add it here. Comment it for yourself. Tell you what it will be. And apply it. In other words, use the thresholds 1, 2, 3 to the conditions 1, 2, 3 and report on the results. Back to the old behavior, which I ended up quite liking, the blue zebra. There you are. I'm going to do one last thing here and give some more output. Turns out I don't really need to see perhaps the new image array, but I'd rather see the percentages of the changes. If that's the case, and I was happy with seeing that, just peel this thing off and say, all right, stuff to report. This is the percentage red changed. Replace. This here is a percentage green changed. This here is the percentage blue that's being changed. Now I don't need quite that much space, so I align them. And since I like to see this as output, if I do, I'll just add them here on the left because I want to see them first. Perk red, perk green, perk blue are going to be outputs. Perk red, perk green, perk blue are going to be outputs. And I'll tell myself perk red, perk green, perk blue is the percentage of red pixels meeting the condition and being changed. And likewise for green and blue. Now, if I run this, I can have space to ask for output. And here's the thing. Inside of it, they're called perk R, perk G, perk B, and they're properly reported by only doing this, writing this line. This is the line. This explains the line. Once I'm in my command line and I execute the function, I can call anything I want. PR, PG, PBlue, Y. That now isn't working because I have a mistake, which I'll fix. What am I seeing? A bracket. Do it again. Still not working. Another change. Another parenthesis. Do it again. Still not working because C size isn't working. What am I doing wrong now? Prod size red. Oh, this is interesting. It tells me numl is usually faster than prod size. Of course, the real problem is that I hadn't calculated the size before I was using it. Now it works. It doesn't give me the output because I've suppressed it. But now if I ask for PR, PG, and PBlue, I can work with these variables in another program. As this here tells me, Matlab tells me numl is faster than prod size, it turns out I suppose I could do that. Numl. I'm hitting the save button. Check that it continues to work. Looking good. I'll do another last little thing. I'll say fig, fig, fig. If it's 0, don't print a PDF. If it's 1, print a PDF. I'll use another control structure at the end that says if fig equals 1, print it. If not, don't print it. Now I won't get a PDF if I don't ask for it, and the way to ask for it is to call it last input 1. If I don't want it, which is faster, I'll just say 0. As I'm writing a function, calling it Zebra, it's not wise to write the word Zebra again. Turns out there is a function for this called mFileName, which is which file were you actually calling. So if I replace the string Zebra with mFileName, it's going to write for me Zebra, because on the inside it knows that it's part of a file called Zebra. I'll show you that by looking at my operating system. I'll go back and I'll remove my file. This is something that you might not be able to do on your own machine in the same way. As you can see, I don't have a file called Zebra PDF. I'm not calling it Zebra, I'm calling it mFileName. And when I run it, forcing it to print it and then look, I discover that indeed it has created that file, which I can look at, and there it is, ready for your report. Since I've been using sprintf, I might as well make a more complex file name. That's going to take a format, at least a string, but maybe here I'll put the threshold values. String for mFileName, I are going to be WT1, WT2, WT3. If I run this now, it's going to save for me a PDF that's no longer called zebra.pdf, but it's called zebra_505050, which obviously is the way to keep track of what you're doing, because you will make hundreds of files while you're deciding what's an appropriate threshold, say 50, 50, 11, 22, 23. Well, I'm now creating a file name with that particular one. And in my research, writing my report, I can take a look at the 11, 22, 23 picture. Or I can look at the zebra 50-50-50 picture. I can print them out if I want to. I can make a little booklet if I want to. And I can see the effect of my choices. So using the functional form of this script that was previously a bunch of command line Matlab, I can now have the complete flexibility of giving it inputs, doing something internally, giving it outputs, printing a figure, and naming the figure something sensible such that I can later remember it. Not quite happy with this yet. I'm going to actually change this format to 3.3i, 3.3i, and 3.3i, because that way I will force it to make file names that actually have the leading zeros. This will be handy when your file system sorts it. You don't want 1 to say 1 if there's going to be possibly 255 values. A better way to do it is to say, well, it's going to be at least 3 and force it to be 3. At this point, you can vary your conditions, you can vary your inputs, you can vary your substitutions, you can add more input, you can add more output, and you essentially, at this point, have the entire Matlab under control. Functions with inputs and outputs, with for loops, with if statements, printing to screen, printing to a figure, making a histogram, changing, substituting, setting variables, changing them, and so on. This is almost all there is to writing in Matlab. The rest of it is more detail, is more possibilities, but it ultimately doesn't get any more complex than this.